So if you look farther out, you also find there are things called clusters of galaxies. So in this picture, you see many of these yellow round objects. So each of them is actually a galaxy of its own, which may contain again like 100 billion stars in each one of them. But you also see that these yellow objects are living together, like hundreds of them. So they are called clusters of galaxies. And you see many of these clusters if you look, observe the universe, and they are pretty common, and all of them contain these elliptical galaxies, which don't seem to have big spirals as our own Milky Way galaxy does. So if you keep observing these things, then you find sometimes very strange objects which look very much elongated, like here. And also there. And you see another one down here. And we'll come back to this question, why we see these very elongated objects. That also has to do with this idea of dark matter. But before getting there, let us just get a look at this movie, which shows how we might actually fly through the universe. And this is actually based on real data from Project Sloan's Digital Sky Survey. So using telescope, you map out where and how far away a given galaxy is, what kind of shape, what kind of color. You put that into a computer and pretend that you are flying through this universe based on the observational data. And of course, you shouldn't try this at home because we're actually moving about and flying through the universe at a speed of like 1 trillion times the speed of light. You can't possibly do that. But anyway, what you see here is that this kind of the ocean of galaxies just keep going on and on forever. No matter how far you go, you pretty much see the same kind of universe anywhere. And galaxies are indeed clustered, so they come in sort of a big families here and there. But again, if you just keep going, you'll find another cluster, another local group, and so on and so forth. So this universe is stretched, way out there. Just keep going on and on. And so if you actually flatten this into a two-dimensional map, and it looks like this. So this map itself is 2 billion light years across. And each dot in this map is a galaxy. And the part that is black, it's not that there aren't any galaxies out there. We haven't actually managed to even observe that. The universe is so big. There's so many portions of the universe we haven't even observed carefully yet. So the basic picture is very clear. Universe just keeps going nearly uniformly. So pretty much universe is uniform. There doesn't seem to be any particular place in the universe. Clearly we're not at the center of the universe in any way. Our place doesn't seem to be any special over any other places. Universe seems to be totally uniform. But there are wrinkles. Some parts have more galaxies, some parts do not. So more or less uniform, with small wrinkles on top of it. So that seems to be the way our universe looks like. And if you're using the big telescope and try to observe as far as you can, you see many, many galaxies out there. And this is a famous picture from the Hubble Space Telescope. And here's a question to you. There is a galaxy in this picture that is at a staggering distance of 13 billion light years away from us. Do you know which one that is? So we start zooming into this picture, and you're looking for something like this little red speck. All these objects, which seem to have these shapes and colors and so on, they're actually close to us, maybe as close as, 7 billion light years from us. That's close, that you can even see the shapes of these galaxies. But far away ones, you don't see even a shape. And it's so far away, it looks very dark. In addition, it actually looks rather red. I come back to this question of redness. So you just keep expanding this picture from telescope. You're looking for this red speck. If you zoom it further up, it looks like this. So this little red smudge is the world record of the farthest distant galaxy observed to date, that is 13.3 billion light years away from us. So universe just keeps going more or less uniformly. You see these wrinkles, but the far away galaxies actually look red. That's one thing I want you to remember. Now, if you do manage to look even beyond these galaxies, what would you find? Nothing. So it turns out that if you go beyond, let's say 13.5 billion light years away, there are no stars out there you can see. It's not limited by our technology, not limited by the size of a telescope, but there simply aren't any stars out there. So what's going on here is the following. Universe began like 13.7, 13.8 billion 13.7, 13.8 billion years ago. And if you look that far away, it takes that many years, the light, to reach us. So you're actually looking the image of the past. So if you remember the fact that sun is 8 light minutes away, what we can observe with our naked eyes, what the sun looks like, is a picture of the sun 8 minutes ago. If you look at Andromeda galaxy, we are looking at the image of Andromeda, how it was 2.5 million years ago. So if you look 13.5 billion light years away, you're looking at the way the universe was 13.5 billion years ago. That was just a couple of 100 million years after the beginning of the universe. So the universe didn't have time to even let a star to be born. No stars existed back then. That's why we cannot see anything out there. So that era is called Dark Ages. Universe was too young to let a star to be born. There's nothing we can see out there, and that's the Dark Ages.